An ellipse is a plane curve surrounding two focal points.
That for all the points on the curve.
The sum of the two distances to the focal point is a constant.
There are two types of ellipses, the vertical ellipse and the horizontal ellipse. Here are some tips on how to identify which formula to use for each type of ellipse. The value of A is equal to half the length of the major axis,
While the value of B is equal to half the length of the minor axis. In an ellipse, the length of the major axis is always greater than the length of the minor axis. Therefore, A squared is always greater than B squared.
To get the major axis orientation, look at the equation above A squared. To get the length of the major axis, or the distance from the first vertex to the second vertex, in each ellipse, just get the twice value of A. On the other hand, to get the distance from the first focus to the second focus, in each ellipse, get twice the value of C.
Depending on which two values are already given, to get the missing value of either A, B, or C in either ellipse, derive the answer from this formula. A squared minus B squared is equal to C squared. For example, if the value of A is 5, the value of B is 4, and the value of C is unknown, then get A squared, which is 25, and B squared, which is 16. Next, subtract 16 from 25, which is equal to 9.
Lastly, get the square root of 9, which is 3. 3 is now the value of C. In another example, if the value of A is 7, and the value of C is 5, and the value of B is unknown, then isolate the negative B squared from the other variables by transposing A squared to the side of C squared.
Next, get A squared, which is 49, and C squared, which is 25. Afterwards, subtract 49 from 25, which is equal to negative 24.
Multiply both sides by the negative sign to make them positive.
Get the square root of 24, which is 2, times the square root of 6.
2 times the square root of 6 is now the value of B. To get the center of any ellipse, get the value of H and K with their opposite signs from the given standard equation. To get the foci for each ellipse, add and subtract the value of C from the value of the variable above A squared in the standard equation.
To get the vertices for each ellipse, add and subtract the value of A
From the value of the variable above A squared in the standard equation. To get the endpoints of the minor axis for each ellipse, add and subtract the value of B from the value of the variable above B squared in the standard equation.
is not given, but the coordinate of the center and one of the vertices are given. Subtract the coordinates that are different from each other.
This can also be done if the value of B is not given, but the coordinates of the center and one of the endpoints of the minor axis are given, or if the value of C is not given, but the coordinates of the center and one of the foci are given. Here is the full summary of formulas that can serve you as guide. You can pause the video if you want to copy it.
If you're done, let's proceed. Let's try solving some word problems to see what we have learned about the ellipse. For the first problem,
What is the equation of the ellipse in standard form, whose major axis is vertical, center is at the origin, A is equals to 4, B is equals to 3.
In this problem, we'll be solving for the standard form, the general form, the value of C, the foci, the vertices, the endpoints of the minor axis, the distance from the first vertex to the second vertex, and the distance from the first focus to the second focus. For the standard form, since the major axis is vertical, our formula should be like this.
the center is already 0, 0 because it is at the origin. That removes both H and K from the equation. A squared should be under Y squared.
Since A is 4, A squared is 16. Meanwhile, since B is 3, B squared is 9. This is our final standard equation.
For the general form, multiply both sides of the standard equation by 144. Simplify both sides, then transpose 144 to the left side. This is our final general equation.
For the value of c, our formula should be 16 minus 9 is equals to c squared. 16 minus 9 is equals to 7. The square root of 7 is equal to the square root of 7.
The square root of 7 is the value of c. For the foci, add and subtract the square root of 7 from 0 to get each focus coordinates. The first focus is 0, comma, the square root of 7, while the second focus is 0, comma, the negative square root of 7.
For the vertices, add and subtract 4 from 0 to get each vertice's coordinates. The first vertex is 0, 4, while the second vertex is 0, negative 4. For the endpoints of the minor axis, add and subtract 3 from 0 to get each endpoint's coordinates.
The first endpoint is 3, 0, while the second endpoint is negative 3, 0. For the distance from the first vertex to the second vertex, multiply 4 by 2. The distance is 8. For the distance from the first focus to the second focus, multiply the square root of 7 by 2.
The distance is 2 times the square root of 7.